Hey there, I'm Dave Hearn, and I'm the director of Kissimmee Park Observatory. In this Star Hopping Extra, we're going to take a break from our normal routine and learn about the different types of star clusters, all the different shapes and structures that these collections of suns can have, and how they might appear in your telescope eyepiece. More about all this great stuff right after this. Stay tuned. Hey, hello, hi, and welcome to episode 21 of Star Hopping with Kissimmee Park Observatory. I'm Dave Hearn, and I'm just over the moon to be your host. In this series of programs, we'll show you the most beautiful sights in the night sky and explain exactly how to find them in your binoculars or your telescope. So this episode is a Star Hopping Extra, a discussion that we have while we wait for the more interesting targets to rise up from the eastern horizon. As spring is fast approaching, a new type of deep sky object will replace the many galaxies that we've been seeing. These are the most numerous type of deep sky object, star clusters. Clusters can appear in three main configurations, and they are open clusters, clusters with nebulosity, and globular clusters. Let's start out with open clusters, which are definitely the most numerous deep sky object up there, with nearly 1,000 of these objects lying within our galaxy. An open cluster can also be described as a galactic cluster. These are collections of stars ranging in number from 10 or so individual stars to a mass of over 1,000 stars that were all formed from the same molecular cloud. All the stars within these groupings have roughly the same age and can appear as loose collections or groupings, or appear so densely packed that it's difficult to see black sky between the individual cluster members. Open clusters are classified by a somewhat complicated designation created by the astronomer Robert Trumpler in 1930. The Trumpler scheme gives a cluster a three-part designation. The first part with a Roman numeral from 1 to 4, indicating its concentration from strongly to weakly concentrated. Secondly, an Arabic numeral from 1 to 3, indicating the range and brightness of members from small to large range, and the letters P, M, or R to indicate whether the cluster is poor, medium, or rich in stars. An N is appended if the cluster lies within nebulosity. Under the Trumpler scheme, the Pleiades are concentrated as I3RN, strongly concentrated and richly populated with nebulosity present, while the nearby Hyades cluster in Taurus are classified as II3M, more dispersed and with fewer members. Some great examples of the different kinds of loose open clusters are the Beehive cluster in Cancer and M7 in Scorpius. Some examples of tighter open clusters are M35 in Gemini, the double cluster in Perseus, and M11 in Scutum. Moving along to a similar configuration of stars, a cluster with nebulosity is an open cluster that is cradled within a stellar nursery of gas and dust, essentially a set of recently born baby stars. These are some of the most photogenic targets in the heavens, as they are very sparkly and colorful in images. Some of the popular nebula with galactic star clusters embedded within them are targets like the Pleiades, the Lagoon Nebula, the Trifid Nebula, the North American Nebula, and the Star Queen Nebula. So are you completely starstruck yet? These are all gorgeous deep sky objects and their images taken at KPO. The last type of star cluster also presents a very impressive and sometimes breathtaking spectacle in the eyepiece, and are known as globular clusters. Globulars are spherical collections of stars that orbit a galaxy's core as a satellite, and there are over 150 of these objects within our Milky Way galaxy. The stars in a globular cluster are very tightly bound by gravity, which gives them their spherical shape and relatively high stellar densities toward their centers. Globulars are found in the halo of a galaxy. They generally contain considerably more stars and are much older than the less dense galactic open clusters, which are found in the galaxy's disk. Globulars contain hundreds of thousands of stars within them, and in the largest ones there are 1 million or more stars. Globular clusters tend to look all very similar, but the distinctive differences are in the way the outer stars spill into the blackness of space around them. The largest and most famous globular is Omega Centauri, lying in the constellation of Centaurus. The second largest of these type of deep sky targets is 47 Tucana, and it can only be viewed from the southern hemisphere. Other amazing globulars are M13 in Hercules, M22 in Sagittarius, M15 in Pegasus, M3 in Boötes, and M4 in Scorpius. If you lived on a planet orbiting a star within a globular cluster, the sky would most likely to be filled with tens of thousands of stars, and it would be pretty white. Amazing. These denizens of the deep sky provide an entertaining viewing experience because the popular ones are relatively bright and can handle a lot of magnification to allow you to zoom in to resolve individual stars near the core. I've heard many gasps of surprise coming from some of our more impressionable guests when they first view a globular cluster through the KPO reflector. So let's look back at what we've learned about the different types of star clusters. First and most common is the open star cluster, also known as a galactic cluster. These vary greatly in star density, brightness, and color, and generally have all of the stars within them being around the same age. Second are clusters with nebulosity, which are found in some of the most beautiful deep sky objects in the sky and often appear sparkly and colorful due to the bright stars and different compositions of the nebula associated with them. Most often these are stellar birthplaces, with the stars in these nebula all being very young indeed. And lastly are the impressive globular clusters, found within the outer halo of our galaxy, containing hundreds of thousands or even millions of stars, tightly clustered together, bound by gravity. It's amazing what wonderfully varied and unique configurations these grouping of stars can take. They certainly provide variety and beauty to our interesting hobby of astronomy. So that does it for this week's episode. You can find the show notes on our website at kpobservatory.org/sh021, where you can comment and leave any questions that you may have. Thanks for joining us, and I'll see you next week with more star hopping tips and tricks.
I'm Cassie, and I hope you've enjoyed star hopping around the Milky Way. We'll continue to bring you these video astronomy tutorials every week on Thursday, and in their podcast format on Fridays. They'll be designed to help you find deep sky objects that are up in the sky at the time we post them on the internet. The reason we create these videos and podcasts is to help beginning amateur astronomers learn the sky and get more enjoyment out of their telescopes and astronomy in general. If you have any requests for potential targets in the night sky that you would like to see us discuss, just let us know down in the comments section below or on our website blog. Don't miss our free field notes for this episode, basically the script of the show, with all the images and star charts we use for our star hopping activities. You can get them for free at kpobservatory.org/fieldnotes. If this is the first time you're checking out star hopping, and if you found this video useful, please consider subscribing to our channel by clicking the big yellow button, click the thumbs up on the video, and please share this tutorial out to your friends who like looking at stars. Also, as I just mentioned, please feel free to leave any question or comment below, and we'll be sure to respond quickly. Please follow KPO on Facebook, where we post all of our astronomical digital images, and keep everyone informed about upcoming astronomical events. We'd love to hear from you to discuss all this great stuff up in the sky. All the links to these places in cyberspace, including our website, kpobservatory.org, can be found below in the episode notes as well. And finally, if you feel this video provides you value, and if you'd like to see more, please consider supporting us on Patreon, where for a small amount per video, you can support our efforts, and help us make even more great astronomy tutorials, just like this one. So bye for now, and thank you for watching, and we'll see you next time on Star Hopping with Kissimmee Park Observatory.